Okay, so in this video, we are going to go over 8.2 practice number 2. So there is a lot of information about this. Quadratic functions make a parabola. A parabola either opens upward or opens downward. And you're going to learn later today that it involves the a value. When a is positive, it's facing upward. When it's negative, it's facing downward. But before we get into the quadratics, we do have a review. So the review is finding the factored form of this trinomial. So you want to find the GCF, which is going to be -2. Your calculator is going to tell you it's a +2, but because the first term is negative, that's why we divide a negative. So we actually have to divide that -2 out. So each term has that -2 divided out. Now, once you confirm your simplified expression, you can start the diamond. The diamond is going to help you with the area model. So you are going to have a new a value, which is the number in front of x squared. You're going to have a new b value, which is in front of x, and you're going to have a new c value, which is just the constant, the end of the trinomial. So a times c is going to be 7, and then your b value is going to be -8. Now there's only two numbers that work here, and that's going to be -7 times -1, and -7 plus -1 gets you a -8. So make sure that you are using the factor chart that is provided to you in the Schoology course. Now that -1 and -7 matter. It matters on the next screen. That -7 and that -1 is how you split up the x's. Remember, we had a simplified trinomial. This simplified trinomial, this is now your first term. This is now your last term. Now this -2 does not appear until the final answer. From there, you have to now find the GCF of each row and each column. So the GCF of x squared and -1x is just going to be an x. -7x and 7 is going to be a -7. And then x squared and -7x is going to be another x. And this is going to be a -1. Now the whole reason, and you can check this, the whole point of this is to get to these factors. These factors are building your binomials. Your binomials are two terms. So I'm going to wrap my red binomial up in parentheses, and I'm going to wrap my orange binomial up in parentheses. And notice that I already put the -2 first because I didn't want to forget about it. Now we're going to get into the quadratics. Now here is vertex, and this is vertex form. So a lot of you guys know that the vertex is going to be -2, -3. But where you struggle, or some of you struggle, is putting it into the equation. So for this one, we'll just make a be 1. And the equation actually already has a negative in it. So when you implant or put that -2 into there, now you're going to have two negatives. You're going to have the negative from the form, and you're going to have that -2 from the h. So in middle school, you learn minus a negative, or a negative times a negative, will get you a positive. So that is why we see the opposite inside parentheses. Now notice the k, it's just hanging on the side. So it's really minus 3. And you can put that 1 or you can put a, it doesn't matter. So you should really have a plus 2 and a minus 3. Now the same thing, we're dealing with the equation. So the equation has that minus sign already built in because we're minusing h. So how do I get a minus 5? I have to begin with a positive 5. And then my k is exactly what I see. The reason why, if you go backwards and you put minus a positive 5, minus 3, minus a positive gets you what you're looking for. For those of you that wanted to put negative 5, be careful. I'm going to do this one wrong, okay? So if you wanted to say it was negative 5, put it in the equation. See what you get. You get x minus a negative 5 squared minus 3. Minus a negative is not the same as what I gave you. So, since it's not what I gave you, this would be incorrect. We can't do that. So it will be 5 and then negative 3. For slide number 6, you always want to start at the origin. Which direction did I go? I went left 2, up 5. So actually write that. Left 2, up 5. Now in math, left and right, up and down have a symbol. So left means negative and up means positive. Now we're going to, and it's concave up because it's facing upward. And now we're going to plug that back in. Remember, what we're plugging in is a negative to something that's already a negative. So a negative times a negative is going to be a positive. So since it's facing upward, let a be 1. And then minus a negative is going to be a plus 2 inside parentheses. And then plus 5. Sorry. And then you have to make sure that it highlights. You want your orange graph to become your blue graph. Same thing for slide number 7. Slide number 7, the only thing is it's facing downward. It doesn't matter. It's still a parabola. It's a hill instead of a bowl, and that's okay. So from the origin, how did it shift? It shifted left. How many units did it shift? It shifted left 2. And then once again, it went up 6. I'm sorry, went up 5. So notice it's almost identical to slide 6, but this one is now facing downward. So all we have to do is put a negative 1, and everything else is the same. So what we wanted you to notice is that 2 different graphs could have the same vertex. The vertex is just one part of the graph. Slide number 8. Remember, please start at the origin. Make it a destination. How many do I have to go right? Man, I have to go right 6. That's a distance. How many down do I have to go? Oh, I have to go down 4. Remember, the directions mean something when we get into the ordered pair. So right 6, down 4. Those directions mean that right is positive, so it's a positive 6. Down is negative, so it's going to be a negative 4. And then you just enter it. And this is concave up because it's facing upward. Since it's facing upward, our A is going to be 1. Minus a positive is still going to be a minus. And then the K is exactly what you see, so it does not matter. The K was negative 4, so that's why I put negative 4. It's only the H value that switches. Same thing here from the origin. If you notice what I'm going to write, I have to go left 7 units. And instead of going up, I have to go down 1, 2, 3 units. So what does left mean in math? It means negative 7. What does down mean? It means negative 3. That's my ordered pair. And then lastly, this part changes things, guys. Minus an H. So this is facing downward. So I know I'm going to have an A of negative 1. So since it's x minus a negative, it would be silly if you wrote it like this. Because in middle school, you learn minus a negative is really a positive. So I'm going to go back and I'm going to delete minus a negative and I'm going to change it to a plus. And it highlights it. Now, the difference between these slides is that I give you the equation. So now I'm asking you for the H and the K. So this x minus is already part of the form. So what is my H? It's just an 8. It's a positive 8. What kind of 4 is that? It's going to be a positive 4. Now where is 8 comma 4 on the graph? It's in the first quadrant. It's right here. So that's what I need you to do at this moment. I'm going to erase this. And I want you to look in front of this parenthesis. Since there's no number there, it's a 1. It's a positive 1. So since it's a positive, we know that we're going to be having arrows upward. So the vertex can be 8 comma 4. Look from the origin. We had to go right 8. And then up 4. Slide number 11, same idea. But notice now that this is a negative sign. What does that negative sign mean? It really means a negative 1 for right now. And that means our graph is going to be flipped upside down. That doesn't change anything about the vertex. The vertex is still the opposite of what you see inside the parentheses. So the H value is going to be a negative 2. And then the K is going to be exactly what you see. Now, where is negative 2, negative 9 on the graph? It's all the way in the third quadrant. It's all the way down here. And since I have a negative 1 for my A, you're not even going to really see the graph because it's underneath. It's going to be smaller than negative 10. So this is going to be concave down since the A was negative. Now slide 12 was not meant to confuse you. Slide 12 was just kind of notes for you. This is the axis of symmetry. I like to abbreviate it AOS. It is always going to be the x value of the vertex. So this is the vertex. What's the x value of it? It's negative 2. So there you go. The axis of symmetry is x equals negative 2. So the axis of symmetry will always go through the vertex every single time. And then I think this is a really neat slide. This slide is helping you with your vocab. Okay, the vocab is really important here. So your vertex is going to be, in this case, it's going to be the maximum. It's the highest, it's the middle point. This is your y-intercept because it crosses your y-axis. And then these 2 points are your x-intercepts. So the nice thing about this slide, the one that I really like, is that all you have to do is click it, -4, 16. From the previous slide, we just learned that the axis of symmetry is the x value. So in this case, it's going to be x equals -4. Y-intercept is where the graph touches the y, which is 0, 12. First, and this is my fault for not preparing you guys, the word 0 is another word for x-intercepts, okay? So that was my fault. I changed it on the other slide, but I did not do it on this slide. And then click on this point, and it will tell you 4, 0. That's not a comma, sorry guys. All right. And then slide 14, exactly the same. If you need to use a piece of paper to label what your vertex is, y-intercept, all that. And it doesn't matter that the graph is now facing upward. So this is an x-intercept. It's key features of a parabola that are really important. So y-intercept is where it touches the y, and then the x-intercepts are where it touches the x's. So this will be 4, -2. Remember here, the axis of symmetry is the x value of the vertex. They are always going to be related like that. X-intercept, 2, 0. Oh, I'm sorry, y-intercept will be 0, 6. It's where it crosses the y-axis. So then the x one is 2, 0. And this will be 6, 0.